What's up, chemistry cool kids? We're back with another video. I'm Kendall, I'm Zariyah, and we're back with some cool chemistry.
First, we're going to start with Boyle's Law. Boyle's Law deals with pressure and volume. P represents pressure, V represents volume. The equation for Boyle's Law is P1 times V1 equals P2 times V2. Pressure and volume have an inverse relationship, meaning as pressure goes up, volume goes down. Here's an example problem. What is my new pressure if I have 450 milliliters of a gas at 100 kPa of pressure, and I decrease the volume to 50 milliliters? Now we're going to write our knowns and our unknowns from the problem. Now we plug in what we know and what we don't know into the equation, and I'm going to divide both sides by 50 so we can get the second pressure by itself. Pause the video to see if you get the right answer. Did you get 900 kPa? Well, good job. Now we're going to move on to Charles' Law.
Next, we have Charles' Law. Charles' Law deals with volume and temperature. The relationship between volume and temperature is direct, meaning that both go up and both come down at the same time. The equation for Charles' Law is V1 over T1 equals V2 over T2, V being volume and T being temperature. An example question for Charles' Law would be, if I had 12 liters of gas at 97 degrees Celsius and I decreased the volume to 5 liters, what is my new temperature? With this equation, volume 1 is 12, temperature 1 is 370, remember after adding 273, and volume 2 is 5. Now we plug all of our variables back into the equation. 12 over 370 equals 5 over T2. To isolate and find T2, we cross multiply. Our final equation is 1,850 divided by 12, and that is what T2 equals.
Now we're doing Gay-Lussac's Law. It describes the direct relationship between pressure and temperature, meaning as pressure goes up, temperature goes up as well. Here's an example problem. If I have a gas at 27 degrees Celsius at a pressure of 1,800 mmHg and I increase the temperature to 127 degrees Celsius, what is my new pressure? Now we're going to write our given values from the problem. Don't forget to convert each temperature given in Celsius to Kelvin by adding 273. Now that we know most of our values, we're going to plug them into the equation and isolate P2. Pause the video to see if you get the right answer. To isolate P2, you multiply both sides by 400. Did you get 2,400 mmHg? Well, good job.
Now we have the ideal gas law. The equation for the ideal gas law is PV equals nRT. Now we have some new variables. We know that P is pressure, V is volume, and T is temperature. N represents the number of moles, and R is a constant, which is based on the unit for pressure that we are using.
An example for ideal gas law is 9 moles of a gas at 347 degrees Celsius and 102.7 kPa occupy what volume? Now you write your knowns from the problem. Don't forget to convert your temperature from Celsius to Kelvin by adding 273. Before I continue, pause the video to see if you can get the right answer on your own. Our next step is to plug in our values into the equation, and lastly, isolate V by dividing both sides by 102.7. The correct answer is 451.51 liters. Yay!
Next, we have the combined gas law. The combined gas law equation is P1 times V1 over T1 equals P2 times V2 over T2. An example equation would be that if I had 2.5 liters of gas at 64 degrees Celsius and 700 mmHg is now subjected to a temperature of negative 33 degrees Celsius and a pressure of 900 mmHg, what is the new volume? Our next step is isolating our variables. In this equation, P1 is 700, P2 is 900, V1 is 2.5, V2 is the unknown variable, so we'll leave that as a question mark. And T1 is, remember, we have to add 273. So T1 would be 337 and T2 would be 240. Our new equation is 700 times 2.5 over 337 equals 900 times the unknown variable over 240. Our next step is isolating V2 so we can get a new equation to find out what it equals. Our first step would be multiplying both sides by 240 and then dividing both sides by 900. Pause the video before I give you the answer. If you got 1.38 liters, you are correct. Good job.